Alright, well, to look for the right differential equation represented by the slope field, what I do is I look for clues, and the simplest way to approach this type of problem is to just specifically look at a single row or a single column of the slope field. So I look at this x-axis, or I look at all the segments on the x-axis, all the slope field on the x-axis, and I notice that all the slopes are 0 because it's just a horizontal segment. Now another thing that I want you to know is every point on the x-axis has y equals to 0. Okay, and x can change, but y equals to 0. And so every point on the x-axis has this characteristics, and also the slopes are 0. So which of these has slopes equal to 0 when x are these and y equals to 0? Well, it can't be the first one because this slope will change depending on what x is, right? So it can't be A, okay? Now, if you look carefully, it can't be B because this differential equation is dependent upon y, and y equals to 0 is undefined, so it can't be B. We're looking for a slope of 0. Now, this one says a slope of 1, so it can't be this one. This one's always a slope of 1. But it's actually this guy, because if you think about it, this differential equation is only dependent upon y. So when y equals to 0, the slope is 0, no matter what x is. So there you go. You found it. You found that, hey, all the slope is 0. Gotta be this guy. All right, very good. Match the slope field with the differential equation. So which of the following matches up with the given slope field? Well, first of all, this is the sine. The derivative is sine, and so on and so forth. Now, remember on the previous problem, example 2, we created a slope field for this part. And if you look carefully, it matched up with this guy. Remember how we did it? We made it a slope field for that part. See? And it matched with that guy. So this is B. Okay. This one looks like it's sine because if you look carefully, the slope of it is very similar to the cosine function. Okay, so it's A, and then we now need to be able to figure out which of these belongs to one of these. Well, we basically take either the x or the y-axis. So I'm going to take the y-axis in this case, because I noticed there's something in common. All these slopes are 0, and every point on the y-axis has x equals to 0 and y equals to something else. So let's see which of these two matches up with that slope. Well, remember the slope is 0, and if you look carefully, when y change, the slope will change. So it cannot be this guy. And it actually turns out to be this guy because when x equals to 0, the slope is 0, see? No matter what y is. So any point on the x-axis any point on the y-axis will have a slope of 0, and that's represented by this differential equation. So we say that's D. Okay. Now, when we search for stuff, look for easy clues. So those are all the ones with the slope of 0, and that looks like y equals to 2. So y equals to 2. What do all these points have in common? It has a y equals to 2, and x can change. So, and if you look carefully, it kind of matches up with this guy, because when y equals to 2, if you 2 minus 2, which is 0, and that's the slope of 0. So it's actually C, right? Now, say if you're having a hard time matching up these guys, then you can also search down, like, if you search down the middle here, it might match up with these two, and then the fact that these guys will kind of bend like it's wavy, that is a signal for a sine function, say, or cosine function. Now, for this function right here, we already know that it matches with B, but you can also look for it by looking at its pattern here, right? So these patterns will kind of tell you that these are the x and the y. These are the x and the y. So as x change, y also change, and if it gets kind of hard to identify the fact that that belongs to this guy, you can always take a few seconds to just kind of sketch a few slope field and see if it match up correctly. Okay. All right. The slope field from a certain differential equation is shown. So they give us a slope field, and which of the following could be a specific solution to that differential equation? So here is a slope field. What is the graph of the function represented by this slope field? Is it an exponential? Is it a quadratic graph? Is it an exponential graph? Is it a decay graph? Is it a cosine function? Now, looking at it, this is the graph of a log function, and so looking at it, it is actually, if you try to sketch a graph and just following this field of slopes, it resembles a natural log function. And there you go.